Hello. Now it is time to process entire session to obtain a final result for this particular precise forestry application. So for this purpose, we launch multi-view terrestrial laser scanning registration. It's called STEP2. Let's prepare our GUI. So what we can do? First of all, we load session. We find session that it is calculated in our previous step by LiDAR odometry. We click and wait. In the console, always please take a look. There are plenty of useful informations that can be helpful in investigating some problems. Okay, our system looks like this. So what we can see? We can see trajectory and point cloud. To improve the visibility, you can change the rendering subsampling. You can choose to generate random colors to have better visualization and other things. So this is our trajectory. The most important information is that in the beginning, in the end, we have some misalignment, and we would like to reduce this misalignment. For this purpose, we have manual post-graph loop closure mode. Let's click manual loop closure, and now we have opportunity to minimize misalignments. So the trajectory is composed of nodes. Each node has its own index, and this index can be typed here, index of the loop closure source and target you can see here. So let's type the first one and the last one. So the last one is 96, and you can see the misalignment. The tree is supposed to be in the same place, but I can see, roughly speaking, 1 meter or 1.5 meter error. For this purpose, we have to add edge, and we can manipulate this edge. Manipulating edge can be done using Gizmo, that we can manually change relative poles between these two clouds, or we can use iterative closest point algorithm that it will do it automatically for us. So let's change search radius to the 1 because we have large misalignment, and let's click ICP button and wait a little. Okay, data are better aligned. Let's decrease the radius and click iterative closest point and make again the decrease of the radius and click ICP 2 times, 3 times, then decrease search radius to 20 centimeters and again ICP, and final search radius will be 10 centimeters and click 3 times iterative closest point. So there is no further improvements in the cloud. You can also check what is going on in console. You can see that the updates are almost zero, so the algorithm giving you optimal solution. Okay, so we have one, let's say, loop closure. So now let's calculate our postgraph slam. For this purpose, we have to set initial poses as a motion model, and then we compute postgraph slam. And you can see data are better aligned. And this is our first step. Now let's find another nice proximities. For example, node 86 and 52nd are close each other, but they are somehow misaligned. But the error is rather small. So we simply add edge, we manipulate this edge, but now it is enough that we click several times iterative closest points because the error is rather small. Then we back to our PostGraphSlam and we compute PostGraphSlam. You can see that our system now has very small errors, but let's introduce further, let's say, nodes that they are close each other. For example, 92nd and 29th. And again, we can add edge. We manipulate this active edge. And let's make ICP 1, 2, 3, 4, 5, 5 clicks. And you can see that the data are registered. So let's back to our PostGraphSlam calculations. And now we have system that has already 3 edges. Let's find another edge, maybe 20 and 39. 20 and 39. Let's add edge. Let's manipulate this edge by clicking 5 times ICP and then back to our PostGraphSlam. Let's find another interesting place, for example, 45 and 61. Let's add this edge. You can see edge is added. And let's refine. Let's with manipulating with iterative closest points. Let's make it 5 times as usual. And then back to compute PostGraphSlam. Let's find another one, another candidate. We can make a risk between 71 and 40. Let's check if we have enough overlap information to register. We don't have, so we can see that it will be quite risky to register this because there is no information on common information on the ground, so we will not do that. Okay. So the last one will be, I can see 31 and 38. So we have very nice overlap. So let's add this edge. Let's manipulate this edge. Let's click iterative closest point to minimize misalignment between those scans in this pair. Let's calculate PostGraphSlam. And let's back to the view of our data. Okay, our data looks very promising. So it is moment that we can save intermediate results. So we are saving session and we call it session LC, like loop closure. Okay, and now it is the final let's say stage of calculations, but before that we can save intermediate point cloud. For example, save all marked scans to LAS. So we have all last that we will see. We will watch it after a moment. And now let's make a final refinement. For this purpose, we unclick Simple GUI and we find Normal Distributions Transform. And here we have opportunity to change parameters in this GUI. So let's just remain default one and type entity optimization. So what in console you can see the progress. So you have 30 iterations. The process is quite long, so we will wait a little. So during this time, we can observe data that we saved as all LC LANs after loop closure. So let's open Cloud Compare and let's take a look of the data. Okay, so we have first iteration from 30, so it will take a while. Let's wait a little. Oh, this is our point cloud after only loop closure. The colors are related with timestamp, so you can see that we go through here to there, and also maybe this color is not so much useful at this moment. Let's change into intensity, and let's make a high contrast to see much better result. So we can see data is already promising. After only loop closure, in step second, we reduce error of misalignment. So the trajectory now is rather okay. Okay, so let's back to our console, check what we have. So we have second iteration. I will make a short break and I will back to you within a second. Okay, after calculations, after 30 iterations of normal distributions transform, we can save our session. So we add NDT and we can export point cloud, save all mark scan as one global scan. So we will save NDT and we can also save trajectory to see trajectory. And we can close our program. Let's check what's the difference between previous data and the finally refined one. Okay, so we have 2 point clouds. One is before normal distributions transfer, so let's change color into solid black one, and the second one will be red one. Okay. To see what's the difference, let's make intersection. So it will be much easier to have some justification. So we have, you can see that NDT data, they are more consistent. So they are candidate to be final result. Finally, let's discuss how to obtain data in full resolution. So we open again our STEP2, our multi-view terrestrial laser scanning registration STEP2. Then we unclick Simple GUI, we unclick Decimate during load, and we load session. And our session is session LC NDT, and let's wait once the session is loaded. Okay, this is our session, and let's save all marked scans into trajectory full resolution, and let's wait a little. In the middle time, we can open Cloud Compare. And we can load our final result. We have 63 million of points. This is full data set. We can also add our trajectory. So let's focus on trajectory. So it will be let's make a solid color to our trajectory. This is our trajectory, and this is our point cloud in full resolution. So let's make let's change color. Okay, give me a second. Let's change from gray to high intensity. And these are all data points that were collected on this particular trajectory. That's all for today. I hope this material is useful, and I hope you can collect more interesting data sets in future. Thank you very much. See you.